I'm going to do two things. One is I would like to just set up how it is that we develop the national assessment climate scenarios, and then from there look specifically at what the climate model results were that were utilized to produce the regional assessment. Then if I have a little bit of extra time, I also mention some of the things that we still need to do in order to achieve a better assessment. This is the path from a climate viewpoint to the national assessment effort and to these regional assessments. First was to select general circulation model studies that all assessment teams would utilize so that we could compare across the country from sector to sector, region to region, exactly what the results were. And we wanted specifically to use N members. There's large differences in emission scenarios, there's large differences in climate sensitivity, so we need to capture some of that range. Another element of this was to utilize historical observations. This places a lot of the climate change and climate change impacts within a particular region into some context. And the third tool that was available to the assessment was to provide a what-if kind of scenario. More frequently this was used to see if you could break the system in some way. What if you had X number of hurricanes within a decade that hit the east coast of the United States? What would be the impact on the insurance industry? So you'd understand what the vulnerability was. In fact, the climate model simulations were utilized more frequently than any of the other data sets because they were tangible, real data that could be applied to different elements of the assessment. So that's the process. With so many general circulation models around the world, you can imagine it's a challenge to select which one you would like to use or which ones you'd like to use. These were the criteria that were provided. One is we wanted it to be part of the Intergovernmental Panel on Climate Change set of model simulations. This provides a context with all of the other different models. It's vetted in that there's intermodal comparisons, there are comparisons with data sets, so there becomes a rich literature on the model simulations. It allows you to compare results for a regional or national assessment with what other models are saying around the world. Reflective range of model sensitivity, which I suggested to try to capture this range, but it was interesting, this first time to do an assessment, we didn't want to overload people with many, many model simulations. We also didn't want one in the middle, because people might actually select a model simulation. So it was better to capture this range, 1895 to 2100. The objective here is you wanted the simulations to be long enough to capture their ability to simulate the last 100 years and compare with observations. You also wanted to have a future simulation. And you wanted them to have consistent emission scenarios. So these model simulations could be compared with each other. You want the runs to already be completed and available in the literature. It turns out this is one of the most critical criteria. If you start to have people from across a community of impact analyses using these climate model simulations and they're not quite ready, then you have people that are working at different speeds and different conditions, and therefore this notion of in the literature, ready, completed simulations becomes an essential criteria if you're going to try to take this step beyond to look at impact analysis. The higher the resolution, the better. Daily saves. The key here for higher resolution and daily saves is if you really want to connect with societal impacts, then higher resolution or an ability to downscale statistically or using other models like mesoscale models becomes important if you're going to connect to agriculture or hydrology or some other component. So the model simulations were actually selected with those two criteria in mind. Output readily available. If it isn't readily available and easy to use, then it becomes a problem. Okay. The U.S. National Assessment and our regional climate study then were based on these two climate model simulations, Canadian climate model, UK Hadley Center model, and you can imagine the consternation that's placed in the United States with no U.S. model on this list. But basically, this was designed to capture this range and follow each of these criteria, and this is what resulted in the process. We wouldn't do it the same way again. Okay, here's what these two climate model simulations look like. The national assessment was done for U.S. Congress. Everything printed in there as part of this is in degrees Fahrenheit. And so this is in degrees Fahrenheit. Left, global mean temperature anomalies. Right, U.S. mean temperature anomalies. A family of climate model simulation runs. Dark black, dark red are the two climate model simulations that we suggested. Dark black, the Canadian model. Red, heavy line, is the UK model. And so you can see that it doesn't capture the complete range, but it does capture a substantial portion of the range. Okay, so results. And this is a temperature increase. It is in degrees Fahrenheit, as mentioned. And this is a Hadley climate model simulation. And with our focus on the Mid-Atlantic region, you can see that the temperature increases on a mean annual basis are predicted from this model to be around 4-degree increase compared to the present day. And if you look nationally, you can see that there are some areas in the west for which that temperature increase is closer to 7 degrees. Canadian model, the more sensitive model. Substantial portions of the nation are above 10 degree warming by the year 2090. This is an average difference for 2090 to 2100. And you can see, for instance, for the east coast of the United States, that their temperature increases between 7 and about 11 or 12 degrees. There are a variety of ways to look at this. One way to look at it is, boy, these climate model simulations are really different, right? 4 degrees, 11 degrees, that's a substantial difference. Another way to look at it is that if we look at all these different climate model simulations, they all suggest at least a 4-degree warming, or at least a 3.5-degree warming on a regional basis. This becomes a significant climate change. If you wanted to pick a particular point, with the red points being the grid resolution of the Canadian climate model, and the blue points being the Hadley model, and the green points being historical observations that are scrubbed and not having any urban heat island effects. And we just picked one here for the Canadian climate model close to where we sit today. This is what you expect to see in terms of the warming. Now, unfortunately, when I printed this, I reverted back to my old self and took degree C, so you'll have to pay attention to the fact that I just changed the units for you. But now you begin to see what the present day average is, blue line, future average is, so you see a substantial increase there, close to what is that, 3, 4, about 5 degrees, and you also see how the structure of the seasonal cycle is different and warmer in each and every month. A comparison for precipitation. This is done as a percent change, so it's a percent change of whatever the precipitation is for a particular region. Again, this is the Hadley model, and what you see is that for the Mid-Atlantic regional assessment, the precipitation estimates are something on the order of 10 to 20% greater than they are for the present day. And this is also associated with increased event rainfall, high rainfall events. We also see quite a bit of structure around the nation just because the picture captures those differences. You see lower precipitation changes near zero that are in the lee of the Rocky Mountains. You see a region in the southwest for which, although we have small precipitation, there's a large increase in what the percentage is. And if we look at the model simulation for the Canadian model, now you see some changes that are substantially different. All of a sudden, we're looking at a Mid-Atlantic regional assessment for which the precipitation is estimated to decrease substantially. You see an area in the lee of the Rocky Mountains for which you have a significant problem. You see the southwest, this same sort of bullseye in a way of higher precipitation. Now, this becomes an absolute critical factor in any type of assessment, because the model simulations are substantially different, and yet how we connect to water makes a huge difference in the assessment. There are some similarities. Both models suggest high precipitation is occurring here. Exactly what's going on there is a warmer ocean onshore flow promotes greater precipitation. It's a logical result of these model simulations. I look at the lee of the Rocky Mountains, and all of a sudden I have this flow structure of uplift over the Rocky Mountains and subsidence on the other side, and it's difficult to bring more moisture to that particular region. And so you tend to see these near zero or even less precipitation associated with that particular region. So these model simulations are very different, yet they also suggest some elements that just make sense based on the characteristics of the circulation. Then again, look at the eastern seaboard. If you're dealing with something like convective rainfall in the summer, all of a sudden you realize you have a significant problem in making predictions. What happens with the temperature, the drying of the surface, the soil, a difficulty of a coarse resolution model to simulate convective precipitation, and you realize then that these are areas for which it's very difficult for us to tell what's going on. A couple of quick examples of what this means for an assessment. We could look at the Palmer Drought Severity Index. The larger the drought, the more of a tendency green not to have drought or brown to have drought. And now this reflects in a large measure that increase in temperature and the change in precipitation. So you see the lee of the Rocky Mountains and up in this particular region as having a tendency towards greater drought, where with higher precipitation in the east and in mid-Atlantic assessment, a lower tendency towards drought. Look at the Canadian climate model. This is where some of us hope that one of these models is right and one of these models is wrong. The same, quite different, the same pattern that occurs in this area. If you can't bring more moisture and you have warmer temperatures and higher evaporation, your drought tendency increases. And so if you're in the lee of the Rocky Mountains and living along the Front Range or something like that, then you have a significant issue. Obviously, in a mid-Atlantic assessment, we now realize that the result we have is strongly dependent on which model it is that we have to produce a simulation with. One less tendency towards drought, one greater tendency towards drought. Okay, one more. To try to connect with people, you can also look at the heat index to factor in changes in the humidity for how the air feels. You can also see structure in here, which gives you a sense of what some of the transference of the global climate model onto higher resolution topography is done in creating a database for regional assessments. You can see for this Hadley model, this region is feeling 4 or 5 degrees warmer. And perhaps Texas is quite a different issue. It's feeling 20 degrees warmer. A Canadian climate model simulation. Southeastern United States is in trouble, and you're starting to see increases in the way that temperature feels to a human in the mid-Atlantic region. Okay, those are examples of the information utilized to produce climate data that can be used to develop a regional assessment of climate impacts. And I would just like to point out that there are some elements here that we obviously need to work on. One of these elements is better knowledge about how the system works. Over and over again, if you look at the assessments, and maybe you will see this as well in the Mid-Atlantic region, what happens to severe weather and interannual variability becomes absolutely essential to connect with humans. What happens to the hydrologic components becomes essential in connecting with humans. And yet you see for the Mid-Atlantic region a huge difference that occurs. Regional or high resolution in order to connect with human activities becomes a major research topic. We also have to have improved ways to deliver this information to users. And we have to develop a much more vigorous connection to those users in order to develop a good assessment process. So with that introduction of climate,
thank you. I got reminded today that women are bound in more ways than one. No pockets. We'll try anyway. Eric set things up in terms of how the assessment of climate itself changed. And then the next question is, if you're going to do a regional assessment, you begin to ask the so what questions. And the questions that we asked in the Mid-Atlantic Regional Assessment were those that were asked of the national assessment overall. What's the situation like now? How is climate going to change, particularly the environment in a region? What can you do to either take advantage of opportunities that are presented by this change in climate, or to reduce the damages that might occur as a result of the changes in climate? And then, importantly, what else do we need to know? And Eric already has introduced you to some of what we need to know. An integrated assessment approach takes all of this information about climate and puts it together with other kinds of assessment in a way that you don't make one problem worse when you make another one better, or minimize one problem when you examine another problem. You need to account for the fact that you've got all of these multiple influences and they feed back into one another, and so you have a broad range of outcomes, lots of uncertainty to account for in the assessment itself. Because we were interested in the impact on people and ecosystems, we necessarily had to have an interdisciplinary approach to this. We needed to look at many different sectors in the economy and in the environment, but that meant that we needed to be able to set some priorities because there was just too much to begin to assess. And one of the criteria that we used was science in the service of humanity. I'm just going to throw this up there. We did have a spaghetti diagram that showed how we were going to do our regional assessment, but I want to focus a lot more on what we did. We tried to look at those kinds of impacts that would be important to the Mid-Atlantic region. This is the region that we studied for our regional assessment. We wanted to look at those that would be most sensitive to climate. We also wanted to look at those that would be most important to the people in the region. One of the things that was unique about this assessment approach that was undertaken at a national level was the participation of stakeholders. Again, this ties back to one of the comments that Eric made. We explicitly included stakeholders in the assessment process because we wanted them to tell us what was important to them, what they were worried about as a potential impact from climate change, and then be able to look at whether those concerns were well-founded or not well-founded. One of the very interesting things in the Mid-Atlantic Regional Assessment was that we went into this assuming that with the modern health infrastructure in the Mid-Atlantic region, we wouldn't have to worry about some of the health impacts that had been mentioned for particularly underdeveloped countries or countries that are subject to substantial impacts from sea level rise. And yet what we found talking with people in the region was that they were concerned about the potential for health impacts, even in the Mid-Atlantic region. And it became clear that we would have to assess the potential for impacts on human health in order for our assessment to be credible to them as the stakeholders. So at any rate, we wanted them to help us identify the assessment questions. We also wanted them to tell us about information they had that we didn't have access to, and that turned out to be very important. By having them as part of the process, it helped make our results something that others in the community might be willing to look at. And we also felt that they could help us disseminate findings once we made them more aware of what some of the impacts and the potentials for adaptation might be. We had an advisory committee that was much larger than most advisory committees are, but the important thing is that it was quite diverse. All right, what did we need to do in the Mid-Atlantic Regional Assessment? Well, what Eric talked about is number 3 down here. We needed to get there first by looking at what this region is like now in terms of the people, in terms of the economy, in terms of the institutions, in terms of the ecosystems. And then we needed to get some notion about how this is going to change regardless of how climate will change. We know that we don't have a static economy. We don't have a static environment for lots of reasons having relatively little to do with climate. And so we needed to be able to look at scenarios for the future in terms of the region and then ask, finally, how climate change as projected using the kinds of information that Eric Barron showed you will affect what goes on in the sensitive sectors, in those sectors that stakeholders care about, and again, accounting for the fact that people are pretty adaptable, ecosystems are pretty adaptable, but sometimes there are threshold points that are real problems, and we might need to be concerned about those threshold points. We also wanted to look at both the good side and the bad side of climate change, look at the potential for benefits as well as damages, and then, of course, figure out what else we needed to know. Again, I'd like to emphasize that we looked at different scenarios because of the tremendous uncertainties we were dealing with in this overall assessment process. And so we tried to take the same kind of approach that had been used for the climate scenario projections of looking at different kinds of models and historical data and what-if scenarios, and do the same sort of thing to look at what would happen to the economy and the environment in the absence of climate change before we layered the climate change on top of all of that. Here's another look at the impacts that are projected in terms of climate for the Mid-Atlantic region. The Canadian model shows substantial warming compared with the Hadley model. The Hadley model shows a substantial increase in precipitation compared with the Canadian model. In both of these, one of the things that I think is helpful to stress is that even though these are 7-year averaged, you still see lots of variability in both temperature and precipitation in both models. And that's sometimes helpful when you're talking with stakeholders to help them recognize that we know that we've got a lot of variability now. We're likely to continue to have a lot of variability even though the trend may change. Using information like that, we were able to come up with projections of ranges for the most important physical parameters and attach a confidence level to that. We know that carbon dioxide is going to increase somewhere between 20 and 30% between now and the year 2030, and somewhere between 50 and 120% by the year 2095, and we've got high confidence in that. On the other hand, when we get to runoff, we're not even sure about the direction of change, and that becomes very important for things like the Palmer Drought Severity Index and what kinds of activities and ecosystems can survive. Similarly, we looked at projections for the future in terms of things like population and income. This is just an example showing that we have a sort of medium projection as a most likely projection, but we also had high projections and low projections for both employment, population, incomes, and so forth to begin to look at what the impacts in the Mid-Atlantic region might be. Well, let's look at some of those impacts. This particular overhead shows the forest cover in terms of dominant species in the Mid-Atlantic region. The top figure here shows the current distribution of dominant species in the Mid-Atlantic region. And if you can't read the little labels over here, that's not important. What is important is that the bottom two show the projected distribution of dominant tree species in the Mid-Atlantic region under the Canadian model and under the UK model. And they're both quite different from that top one. And so what we have is a situation where we know that what we see in the forests is going to look different in 100 years than it does now, and that has implications for things like recreation, for things like ecosystems, for things like the fact that in this portion where all of that red disappears, we're going to lose a lot of the hardwoods that currently are important for furniture manufacturing, which is an important occupation and form of livelihood for many of the rural communities in that portion of the Mid-Atlantic region. We also looked at ecological impacts, and here's an example of birds. We thought birds would appeal to lots of people because everybody watches birds in their backyard. And if we look at perching bird species in particular, in about 30 years we probably will have about a 1.8 to 2 degree increase in temperature. And for the perching birds, we're going to lose 6% of the species that currently are in the Mid-Atlantic region. However, there will be some species that will migrate north because the climate will become more attractive for those species. We will still have a net decline of 3% of the species in the Mid-Atlantic region as a result of that, if these projections are correct. If we look at a subset of the perching birds, the warblers, we see a substantially larger gross decrease and a larger net decrease as well. And people say, well, you know, only 3% of the bird species among the perching birds will be gone. And that's true, but we have not looked at whether the ones that migrate in fill the same ecological niche as those that are pushed out as a result of climate change. And so being able to look at these net changes is interesting, but it doesn't tell the whole story. Similarly, we looked at freshwater fisheries, which are interesting because there will be an increase in the warm water fishery and a decrease in the cold water fishery. So we're going to be better off or worse off. And we thought those who, and this is primarily for recreational fishing because we don't have a whole lot of commercial freshwater fishing in the Mid-Atlantic region. At any rate, one of the things we expected was that the cold water fishermen would tell us that they're worse off and the warm water anglers would tell us that they're better off. And we were quite surprised when it turns out that even those who are going to have more fishable habitat available to them prefer the status quo and are willing to pay something like $4 or $5 per year to maintain the status quo rather than have more of the fishing that they like. We wouldn't have known that if we hadn't asked. We also looked at the potential for health impacts, as I indicated earlier. This shows some data for 2 of the urban areas in the Mid-Atlantic region. We have it for some other urban areas as well. And the interesting thing is that we currently have excess mortality in our large urban areas as a result of heat waves in the summertime and as a result of cold waves in the wintertime. And those numbers are likely to go up. In Philadelphia, instead of 146 deaths per year, we could have as many as between 300 and 700 deaths per year in the summertime, accounting for changes in population and changes in age distribution in Philadelphia by the year 2050. That does not account for adaptive actions like having more of the Philadelphia heat warning system and so forth, but it tells us that maybe we need to think more seriously about those. On the other hand, these numbers are tiny in terms of the health status of the Mid-Atlantic region. The death rate in the Mid-Atlantic region is just under 900 people per 100,000 population. And so if we have 146 summer deaths that are excess deaths in Philadelphia, and you start multiplying that by how many 100,000 people there are in Philadelphia, you can see that these are very small percentages. But that doesn't mean that we can take comfort in them, and any excess death is something that is wasteful and makes people very unhappy. Now, if we put all of this together in terms of the kinds of impacts that we looked at, we end up with our one-page summary. And that shows you that we looked at a broad range of impacts in the Mid-Atlantic region. We tried to indicate that we had differing levels of confidence in the impacts, that we had both positive impacts, blue arrows, as well as damages that were projected to occur as a result of climate change. Again, accounting for feedback effects, accounting for adaptation that would occur more or less automatically rather than necessarily being planned in response to climate change. And there are some interesting features in this table. For example, this first one, agriculture, has both positive and negative impacts in the Mid-Atlantic region. And the reason for that is that we think corn and soybeans will grow better in the Mid-Atlantic region. That's the positive arrow. The negative arrow, interestingly, is because we also will have better growing conditions for tobacco in the Mid-Atlantic region, which is a very important crop in Virginia and the portion of North Carolina that was on the map. However, tobacco is going to grow so much better elsewhere that farmers in the Mid-Atlantic region still will end up being at a competitive disadvantage. Even though their costs for growing tobacco will go down, they'll go down more elsewhere. And so we'll still have a negative arrow for this portion of agriculture. Another interesting thing about this summary diagram is that most of the arrows are on the negative side. And the bigger arrows show relatively bigger impacts. This gets a little tricky because remember I told you that the health impacts are big in percentage terms, but small in absolute terms. But we do think that we might have some very large negative impacts in coastal areas because of damages to infrastructure from sea level rise, and the fact that even if we don't have more storms, which is possible, that we'll still have the damages going farther inland than currently. We also will have damages to ecosystems as a result of sea level rise, and the fact that so much of our development is in the coastal areas means that it's harder for those ecosystems to migrate inland than otherwise would be the case. We're also concerned about ecosystems in terms of biodiversity overall for the Mid-Atlantic region and in terms of ecological functioning. But this is a way to begin to get some sense of what things we might want to be able to take proactive steps to moderate in the Mid-Atlantic region. Now, in terms of sort of bottom line results, I worked in a federal agency long enough to know that you have to have bottom line. What we concluded was that in the Mid-Atlantic region, in many ways, we're very fortunate because the economy is diversified and therefore likely to be quite resilient. There will be some distributional concerns for particular groups and particular locations within the Mid-Atlantic region. On the other hand, we're really concerned about the fact that ecosystems could be at high risk in the Mid-Atlantic region as a result of climate change. And there's a whole lot we don't know. Is this a gloom and doom story? Well, yes and no. Mostly no from my perspective because there are lots of things we can do now. And the things that we can do now turn out to be the same kinds of things that people have been advocating for a long time related to the sorts of stresses that people put on communities and ecosystems. So we ought to do smarter development. We ought to manage our watersheds better so that we have coastal protection where it is cost effective and we control where we develop when it isn't. We ought to have better incentives so that water is priced at something reflecting its societal cost rather than being subsidized. We ought not subsidize development in floodplains, which we do now. It's not as bad as it used to be, but it's still bad. We also need to disseminate information so that farmers and foresters will have better indications of what kinds of impacts might occur from climate change so that they can incorporate that into their planning about what sorts of crops and trees and so forth they might want to grow. And we think we probably also need to monitor for disease vectors, partly because of many of the changes that have occurred in the last few years that seem to be weather related. We have substantial information gaps. We need to know what it's going to cost to adapt and what the benefits of adaptation will be and how overall policies will affect what we do about climate. There are a few copies of our report on a chair in the back, and it's also available on our website. And with that, we'll open it up for questions. For either Eric or me. Yes, we did. Yes. Right. Again, we used projections, and we had high, medium, and low ranges, just as we use projections for climate.
For example, the Audubon Society in New Jersey has estimated that the number of perching birds in warblers or whatever has decreased dramatically because of the decrease in forest coverage because of the overpopulation of deer in the last 10 or 20 or 30 years. And so, how does someone like me, who's a layperson, put into context a 6% decrease in perching birds over the next 100 years, whereas in my forest at home, I probably have had a much faster change in the perching bird population just due to the overpopulation of deer, which is not just because of human beings, it's because we don't shoot them.
Right.
So I'm going to put all this in context.
The question you ask leads to a much larger question, which is how do we get downscaled to the size of the region that people really can relate to? And one of the things that we struggled with, and Eric will reinforce this, I'm sure, is that we're much more confident about the projections of changes over long periods of time for large regions. And when we get down to something as small as the Mid-Atlantic region, the scientists get very nervous about projections because the science is just not good enough to be very confident about just what will change within the Mid-Atlantic region. And then we all turn to one another and say, but the Mid-Atlantic region isn't uniform. It's got inland and coastal areas, it's got mountain areas and low-lying areas, it's got urban areas and rural areas, it has forested areas, it has agricultural areas, and that makes it very, very difficult to project what's going to happen in your forest, your woods, as a result of climate change.
I think you also have to realize that that means you have to make a lot of different connections we haven't made yet. So, for example, if the deer population is also reflecting warm winters, and a year to 2 years after a very warm winter, you have an explosion in the deer population just because you haven't been culling deer with the temperatures and you're getting a higher reproduction rate, then that contributes one problem to the next. And those are things where you can have a direct impact because of the climate change on a bird population, but we haven't yet taken the step to look at it in a coupled mode. The second thing we have to do is to begin to look at multiple stresses and realizes that the actual change you see on the street reflects the climate change, the land cover change, and also humans' ability to produce waste products that turn into pollutants. And all of those things have to be coupled together. So I would look at this as a first step in understanding the sign that's related to a direct climate impact, and then realize that many of the things that you see locally are either those combined set of stresses or the fact that climate is connected with other parts of the system, and we have to get to that point before we actually see what the actual impact is on a bird population. We all wish we knew what was going to happen next in the national assessment. I think one of the things that we see is that in the first part of the national assessment, which came at the end of fulfilling the requirements of the U.S. Global Change Program Research Act from Congress, is that we worked hard to put that assessment into place. But in the process of working hard to put it in place, you don't use U.S. climate models because the U.S. system wasn't designed as one where we were producing model simulations and ensembles just for an assessment forecast. And instead, we looked at other models that had that data and long-term simulations that were available. I mean, in my view, that's really inexcusable. And one of the things it tells you is that you need to plan ahead and do these things with more advanced warnings so that you can begin to set up these climate model simulations, begin to vet them, begin to have everybody used to them, and then to be able to launch the next part. A huge stakeholder community became involved in this process, and Anne described that quite well. And you don't want to give up on that particular element of it. There's a list of topics that follow as critical elements of the research agenda because we finally learned some of the things that we need to do in order to make some of these connections, the example that we just gave. And so from my viewpoint is you need to start now in order to begin that particular process. But, of course, people are very concerned about the politics of an assessment process. It costs money. We're in the midst of changing the scope of USGCRP and introducing a climate change research initiative from President Bush. And so what's going to happen to assessments and regional studies is not clear. And in some ways, I think it's very unfortunate that we don't get to begin to think through this step right away, because we've come a long way. We also realize that what we did was not good enough, in my view, and we need to take those next steps.